Hi, and welcome to this next video in the trigonometry series, and this is going to be just a real quick one, just going through this idea of exact values for certain values of trigonometric ratios. It's one of these ones where there was more emphasis back in the day when it was non-calculator paper. You've now got your calculator, but having said that, there are still values that you need to be aware of, recognise where they come from, and recognise them when they pop up in questions. So here we go. What we're going to find is that the vast majority of values from trig ratios are irrational, so that they're decimals that go on forever, and you end up doing some rounding. But there are some that we can write as surds, and there are also some that you can write as a rational fraction, i.e. using integers. And so we're going to have a quick look at those ones now. As I said, these values, you can get them off the calculator. You've got access to your calculator, but it is well worth making sure you know where they come from and recognise them when they pop up. And they're going to come from multiples of 45 in the first instance. So let's just have a little look at what's going to happen. So if we take a right angle triangle, an isosceles right angle triangle, each side length there is 1. That's what's giving us the 45-degree angle in the corner there. And clearly we've got the hypotenuse there is root 2. What that means is that if I wanted to do the sine of 45, I'm doing opposite over hypotenuse, so that's 1 over root 2. Or as it'll appear on your calculator, because the denominator gets rationalised, root 2 over 2. As it turns out, cos 45, exactly the same thing, because we've got adjacent over hypotenuse, so that's root 2 over 2 as well. And then tan 45 is an even easier one. Tan 45 clearly is going to be 1, because in that isosceles triangle, the opposite and the adjacent sides are the same length. So tan of 45 is 1. So what this means is those values are all expressed in terms of surds, or they are rational, and at the same time this would apply to multiples of 45. So for example 135, 215, no I don't mean 215, 225, sorry, 315, and so on. Those kind of values as well will pop up with root 2's appearing. So multiples of 45, that's the first one. Next ones are 30s and 60s. So again with this one, how do we derive them? Well, what we're going to do this time is take an equilateral triangle, each side length 2 this time, and that gives us clearly an equilateral triangle, an angle of 60 degrees in the corner. And if we split it in half, what we're doing is creating a right angle triangle. And now that red dotted line there, if we think about what's going on here, I'm just going to use my mouse to demonstrate, that length there is clearly 1 unit, because it's half of that side. And so we've got 2 squared minus 1 squared, square root it. So that means that value there is root 3. And so you can see, same as we had before, we're going to be able to get our 60-degree angles, but also we've got a 30-degree angle in that top corner there. So we're going to be able to get our 30-degree angles off this one as well. So here we go. Sine of 30, so opposite over hypotenuse. And if we're talking about the 30-degree angle, that side's our opposite. So that's going to be a half. Cos of 30, we're talking about adjacent over hypotenuse, so there's my adjacent over hypotenuse, so that one is root 3 over 2. Tan of 30, that's going to be 1 over root 3, or as it pops up on your calculator, root 3 over 3 once the denominator is rationalised. Exact same principle for our 60s, and what we're going to find is they're basically the same values but just flipped around. So this time it's sine 60, that is the root 3 over 2, cos 60 is a half, and tan 60 is root 3 over 1, which is just root 3. And again, you can see that link between sine and cos, because we've got the, for example, imagine that sine of x is the same as cos of 90 minus x, because, like I said, this is basically using the same lengths, just kind of flipping them around in terms of which one's the adjacent and which one is the opposite. So there you go. There is your basic multiples, and again, multiples of 30, multiples of 60. So, for example, 150, 210, 330. All of these things we'll be able to express as square roots or as rational values. And there are a few more that you can do, but we'll see those later on when we get into something called addition formula. It works with things like kind of 15s and 75s as well, but they are a little bit more complex. But these ones that we've got on the screen on the previous slide, they're the ones you need to be able to know and recognise, and you'll see questions involving these popping up fairly regularly. Okay, that was a nice quick video. That's that done and sorted, and then on to the next one, and I'll see you in the next video.